Hi everybody. Today I want to look at a question where an object starts and lands at the same height. So in this question, stunt driver is traveling. He goes up a ramp, jumps, and then we want to figure out how far away the other ramp should be so that he starts and lands at the same height. So this is the second scenario. So I'm going to write my information down so I can move this ramp, erase it. And we know that he has an initial velocity of 30 meters per second at an angle of 20 degrees because that's the angle of the ramp. We know that the initial height is 4 meters and the final height is also 4 meters. And we know acceleration is still gravity. Remember that there's only acceleration in the y direction but not the x direction. And in order to figure out how far we go, we need to know how long it's in the air, so we're going to find time. So the last one that you watched was typed out, but this one isn't. But this is basically the same formula we use for all the scenarios, and then we just make our adjustments. So Vy naught t plus 1/2 at squared. Remember that Vy naught is equal to V naught sine of theta, and Vx equals V naught cos of theta. And recall that the x component always stays the same, so your velocity in the x direction stays constant the whole time. Your y changes as you go up and comes back down. So I'm going to fill in my numbers. That's 4. That's 4. This is going to be V naught sine theta, so it's going to be 30 sine of 20 times t plus 1/2 negative 9.8. Remember, we're back to using the negatives because we don't have any arrows to give us directions. T squared. You could put that in a quadratic solver. You can put all of them in a quadratic solver. This one you don't have to though, because the 4 and the 4 end up giving you 0. So 0 equals, and this number right here is 10.26 times t minus 4.9 t squared. Of course, then we can break it into, we can find a common factor of t out of there, or cancel a t out. We know that one of them will be 0 because we started at a time of 0. So the easiest way is just to do the math on this one. I'm just going to do it quickly and then I'll show you the answer. So now that I've plugged my numbers in, I've moved to the 10.26 t to the other side. There's a t on both sides, so I cancel out the t and leave me with t on this side. Do the division and I end up with a time of 2.09 seconds. So he's in the air for just over 2 seconds. We want to know how far to put the other ramp, so we have to find how far the car travels. So we use this formula, which we've used before. Remember that Vx is the same as V naught cos of theta times t. So this would be 30 cos 20 times the 2.09. And it's rounded down slightly, so the answer works out to be 58.91 meters. So as long as they're 58.9 meters apart, you're good. You can go a little bit shorter and probably still land the ramp. If you go longer, you're going to crash into the ramp and you're not going to get the job done. Now, this way, using this formula works well. If you read ahead, or you read what you're supposed to read, you'll notice there's another formula for symmetrical trajectories. And this is a symmetrical trajectory because we start and land at the same height. So I want to show you how the alternate formula works. Because they start and land at the same height, we can use this formula, which says r equals, and it's a special formula, so it's got this capital R, but that stands for the x of the range. And it's negative V naught squared times the sine of 2 theta all over g. It's an ugly g, sorry. So the range is equal to negative, and it's the negative of 30 squared times the sine of 2 theta, so that's going to be 2 times 20 all over, and the g is soon to be negative, so that's going to cancel out that negative for us. When I do the math, that's going to be 900 times the sine of 40 degrees divided by 9.8. The range works out to be 59.03 meters, which is slightly farther than this, but I rounded this down from 2.0934, something like that. So it's slightly different, but not much difference. So these two methods will work, but this only works if y and y naught are equal. If they're not equal, this formula will not work. You can get close, but it won't work. It's not going to give you the exact answer. So there's two methods to do it. Either one will work. You can find these if you find the other symmetrical trajectory formula for time. You can also use it to find the time instead of this one. It's just a rearrangement of that anyway. So either method will work. I hope that makes sense, and I'll see you in the next video.